Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. You know, I want to open up this video with a shout out to the machine tool technology students at Lincoln County High School in Fayetteville, Tennessee. I got a fantastic email from their teacher, Michael Lay. If it's actually Lee, forgive me, Michael. Let me know that you guys watch my material and it's part of your curriculum or part of your interest. And I want to thank you for that. I am truly flattered by that, so thank you very much. New addition to the board, Hilltop Machine Works checked in from Virginia. They're going to go up on the Wall of Fame here in a second. And today I'm going to show you how to pick up an edge of a part with the dial indicator. A lever style dial test indicator for those of you that want to split hairs about terminology. Now, I've been asked, is it more accurate to use an edge finder or an indicator? And if you think about the logic behind that, the more accurate way would be to use the indicator. And why is that? Well, once you're over the edge with an indicator, there is no movement to find the edge like you would have to do with an edge finder. Edge finders are fine. I use edge finders 99% of the time. The one time that I need an indicator is usually very specific. But we're going to do it with a technique called a projected surface, because it's easy to find the outside of a part, right? Well, when you swing the indicator 180 degrees, you have to bend the tip on the indicator, like this one here. Well, I guess that's too small, right? Let's use our Texas indicator here. As you swing the indicator around, you're making contact with the vertical surface, but when you get on the other side, you can't access that surface. So that's where the technique from project the surface comes in handy. And that's actually a wall clock. It's a great wall clock, isn't it? I had to throw that in there. All right, let's get on board here and show you exactly what I'm talking about. Now, when you sweep with an indicator, it doesn't matter if the center of the indicator, we're looking straight down the spindle here. Here's your part. Let's say the spindle of the machine is out here. As you swing your indicator, what you're going to be looking for in a setup like this is the high reading on the dial, because as the dial comes around, I'm going to draw this arc broken here so it makes a valid point. This reading here is going to be greater than the contact reading. So you're going to see the indicator peak out and come back down. If the center of your machine is over here and you're swinging an outside arc, well, naturally it's going to be the low spot. And I'll do that, both of these on the machine out there to show you exactly how that's done. Picking up the outside of the part is no big deal. No big deal. All day, all day. Promise I'll put that back up. So here's the idea behind a projected surface. I did all hell breaking loose today. Love it. Here's the block. Here's the indicator tip out here. Swung it around, you picked up the outside edge. Now you have to move over, move the machine, not the indicator tip, move the whole machine, move the part, whatever. Then you put a shim against the outside of the part. And you physically hold that shim in place while you do exactly the same tracking operation from this side. So you've picked up the surface on the outside, you've set your zero on your digital, set your zero on your lever type dial test indicator, and when you move over and you pick up this side without moving the indicator, now you look for that zero that you just set, and then you read your digital, split the difference, and you're over the edge. Or read your dials. But make sure if you're using dials, if you don't have a digital readout, if you're using dials, make sure that your motion of your table is always in the same direction. You don't want to go into something and then back against something, because then you got backlash to worry about. And it's just easier to make your move linear, which means when you indicate this side, you're going into the indicator. When you indicate this side, you want to load that indicator beyond zero and move the table in the exact same direction so that the needle relaxes into the zero position. That's a little bit much to comprehend, but I will show you that as well. So let's take a walk out to the mill, set the indicator up, pick up all this stuff that fell on the floor, and I'll show you what it's all about. Take a look. All right, guys, before we start this demonstration, I think it's really important to just cover one basic essential with using an indicator, and that's what I call aligning it to the center of the part. You can see that indicating this blue piece of material right here, that the body of my indicator is tracking straight across the center line of that part. Okay, when you're coming around with your indicator, you want your indicator to always be true to the feature that you're indicating. Now you might say, oh, well, is there any other way? Yeah, there is. This is what I call dragging an indicator. When you come around for the high spot, the body of the indicator is no longer in line with the part. Okay, you can see that the tip is right where it needs to be for the purpose of the operation, but the body of the indicator is skewed. So when you're going to do something with an indicator, make sure that your indicator is in line with the feature of the part that you're going to do. It's a good practice, and you'll get a more accurate reading if you're actually looking to measure something, which you shouldn't be doing with an indicator, but you'll get a truer representation of the error that you are looking for. Okay, let's get on with picking up this block, show you how to use this indicator to find this edge really accurate. When you're spinning an indicator on a machine, make sure that you pay attention to the dial. Now this dial says brown on this side and sharp on that side. So I always reference, if I'm sitting my needles on 5, I call it a brown 5 or a sharp 5. That way when you're looking at it in the mirror or you spin it, you don't forget or lose track of what you're looking at. Okay? Pick a reference. I know that Starrett, half the dial is yellow, half is white, and that would be the reason why. On this Best Test lever type dial test indicator, I always use the brown or the sharp as the reference. To start, we're going to pick up this edge right here using a shim and a projected surface. We're going to hold the shim against the block and indicate that projected vertical surface to pick up this edge right here. We're going to make sure, now this was the part on the inside board, that the final movement of this block is going to be in that direction. This block is going to be moving this way when I pick up the 0 here. Now you're saying it's going to move away. True, it will move away from the indicator, but we're going to preload that indicator and then we're going to slide the block until the indicator reads 0. It'll make a whole lot more sense once you see it done. Shim is on the edge. The indicator's in position. It does not matter what side of the block the spindle is on, okay? Because you'll be swinging the outside radius or the inside radius. It doesn't matter, so take a look at this. Put the edge on. I'm pulling the block back into it, which is contrary to what I said, because you know which way the table wants to move. I'm going to leave that red arrow there so you can pay attention to what's going on. Backing the block into the indicator. Right there is 0. You see I'm about 10 beyond. I'm going to find the high spot on the indicator, which is right there. I'm going to leave it alone at this point. Now I'm going to move the table in the direction of the red arrow to get that indicator to go to 0. Boom, 0. Going to double check the high spot. I like it. Now it's going to start to make sense. All right, once you've got a 0 reading on your first projected edge on your block, 0 out your dial. If you think there's been any movement of the lead screw, double check the indicator, make sure the 0 on the dial still has a 0 on the indicator. If you don't have a digital readout on your machine, put a couple of pieces of tape on 2 mating surfaces and put a reference mark on it so you can tell basically where your dial was originally zeroed. It's a cheap and easy way to label your table. There, 0. Now any movement, you can find your original 0 pretty quick. Take the indicator and spin the indicator 180 degrees to the other side of the block. Drop it down below the surface. Now which way do we have to move that block in order to get to the indicator? There you go, in the direction of the red arrow. This makes it so you don't have to worry about backlash if you do not have a digital readout. My digital readout is on 0 and my dials will be set on 0 here. Actually, I set them before, but I think I just edited that segment in there. Let's move the block over. We're going to measure this gap right here on the dial and on the digital readout, and then we're going to split it. So let's move this over until we have 0. Do not assume that the 0 on the indicator is going to be true when the block makes contact. Sweep the indicator the way you did on the projected surface. Here we go. 2, 4, 6, 8. Coming around for 10. Boy, that's pretty close right there. Okay, we have 970 and change. At this point, take the 970 dimension and split it. If you have a digital readout, this is where you would take the digital readout, hit the center line function, and then select the axis that you want the center line of. Take the indicator off the part and make my shift back to the indicated value based on where it was previously. Now you'll see when the indicator tip spins, repositioned over the edge, that indicator tip should stay right about that edge at 180 degrees to the other reading, which it does. When you're swinging an arc this small, it is really difficult to get the indicator to read 0 and behave itself. Let me see if I can fool around with this for a second and do that for you. Without getting in the way of the camera. It's like working with somebody else's hands. I hope you can see that. The 0 is up here at around 11 o'clock on the dial. I'm going to lift it up, swing it 180 degrees. When I put the shim back on here and apply a little bit of pressure, that needle should go back to 0 or very close to it. I'm 3 away. I'm going to make my adjustment and call it a day. Zero. Now guys, I think it's really important before I drop this needle down onto this surface to tell you that occasionally an indicator tip like this, when you drop it down, if you're splitting the diameter of the ball on the end of that, that needle is going to want to kick out or move the indicator body itself. Get the ball close to the surface, put something on there and preload that ball back where you think it needs to be. Physically move the ball. Okay, I'm going to go a couple thou beyond. And now I'm going to drop the indicator down onto the surface and remove the shim. And when I track, that needle is right on the 0 as well. Now the advantage to using an indicator versus an edge finder, once you dial in an edge finder, you still have to move the table and assume that you're over the edge. There's no way to verify that edge with an edge finder once you've moved the table. With an indicator, there is no doubt you're over that edge. If you're so inclined to use that projected surface again with a gauge block in here, once you have your zero set, you can swing around to the opposite side. Using the projected surface, you can make a table shift. I don't care if you're using an adjustable wrench instead of a crank. You don't need the dials. If you have an indicator and a projected surface and gauge blocks or standards, you can put that table anywhere you want it. I hope that helped. It is a little confusing until you do it a few times, but give it a go. You'll be glad you did. Thanks for watching. All right, well, the dial indicator is something that's full of information. Just that needle moving around on that dial, it is actually talking to you, and I plan to show several other reasons why the needle's jumping around and exactly what you're looking at. It's not just jumping around, it's telling you something. So if you can analyze the movement of that needle, then so be it. And hey guys, to all my machine tool technology students up there in Lincoln County High School, once you learn something in any subject that you've learned it in, teach someone else, pass it on. Makes a difference. Okay, I will be doing a series on this dial indicator. I have a CNC machine. I'm going to make a variety of different shapes. We're going to indicate them. I'm going to show you exactly what that looks like, and we'll be using the dial test lever style indicator the whole time. Thank you very much for tuning in. Joe Pye, Advanced Innovations in Austin, Texas. I'm out.